Okay, today we are going to be doing two things. One, learning about the laws of exponents, the three and most magnanimous laws of exponents. And the second thing that we're going to be doing is learning how to actually use the videos. Okay, so actually do your homework and know how to do it. I know this might be unusual for some of you, but practicing in class to me is the most important thing. So watching these videos at home is the next most important thing. All right. So you should already know your rules of exponents, but it's been a summer, so we're going to look at them again. No, this isn't happening. So we're just doing the rules of exponents. Okay. So the first thing that you have to know when doing the rules of exponents is what is the base and what is the power, or what is the exponent. So technically this whole thing here is called power. X is the base and 2 is the exponent. I know other languages, they call it indices or things like that, but we call it an exponent. So those two together create a power. And then from there, if you know those two things, the rules tend to come a little bit easier. Okay, so when you're doing this homework, you're watching the video and you're like, hey, I kind of understand this, I can move on. Or if you don't, you can pause it, go backwards, and watch it again. Okay? So for this part, you should take a second and see that if you understand which one of these, so there's 3 examples here, that you're clarifying whether you actually do understand if it's a base or an exponent. Okay? Or if there isn't a base or whatever. Any of the questions. So what's the base? What's the exponents? You're going to take a minute and figure it out. Okay. So the base in this one is the 2, and the exponent is the x. So base is the big one, x is the little one that's an exponent. So with something like this here, you may want to go backwards, meaning instead of finding the base first, you might want to find the exponent first. So if I'm looking at this, there's more than one piece that looks like the base could be a part of. So you're like, all right, what's the exponent? And poor example here, but this guy right here is the exponent. Okay, so what is the base? What is being raised to the 5th power? Is it the x or is it the 5x? And what you have to understand is there's no parentheses. See, this one has parentheses, which means all of this is going to be the base. Okay, this one doesn't have it, so it's only connected to what it's directly next to. So x is the base, 5 is just the coefficient out in front. So then we have this one, as I just said before, the base would be negative 3y, and the exponent is negative 5. So you could have done this one backwards also. Negative 5 is being the base. What is being raised to the negative 5th power? Well, that's this whole mess because of the parentheses. All right, so then just so you understand, when I use the word base, what that is, and exponent, what that is. That's what that's about. All right, then we talk about the 3 rules. Okay, so in most of my videos, we're going to have some sort of lesson, and then we'll do a couple of examples, and then you'll have a couple of examples to do and to submit to me so that I can see how well you guys understand these pieces. So rule number 1 looks like this. Now this may seem crazy to you, especially if you do try to watch these without sound. But when you're looking at this is saying x to the a times x to the b equals x to the a plus b. So what does that mean? In English, instead of math, it says when you multiply bases, so I'm multiplying the x's together, you add the exponents. That's the rule. Now, if you don't understand that rule, I can do a brief example of what that means. So if I said, okay, x squared times x to the third, that is x to the fifth. Okay, because I added the 2 and the 3. The reason being is x squared can be rewritten as x times x, and x to the third is x. So look at that. There's 5 of them. That's x to the fifth. I wish we did simple examples like that all the time, but we don't. So a basic example of the way that you're going to do this, you could always expand it like that, but we're going to be doing negative exponents, fractional exponents, so you do have to understand the basis for this. Okay? So what we look here is we have bases. X and y are bases. X and y are bases. X squared, 2 is the exponent. What's the exponent on the y? Well, if there is no exponent, it's a 1. So sometimes I put those in so that I can see what is the exponent. Here, the negative 2 and the 3, those aren't the same numbers. Yeah, we're not going to go into making this more complicated than it is. These are considered coefficients. We multiply those normal. So you multiply the negative 2 and the 3 together, normal, because they don't have a different exponent. There's nothing really on them that makes them special. So we are just going to say, okay, that's negative 6. And now we're going to multiply x squared times x to the fourth. So when we multiply those bases, we're going to add the exponents. So 2 plus 4 is 6. I mean, you can expand it out. 2x squared. Look at that. There's 6 of them. But you want to get out of that habit and get to the next step. Okay? So we have y to the third and y to the first. That's y to the fourth. Now, you may be asking yourself, why are you doing it one by one? Shouldn't you just have the answer and multiply them all together? Yes. And that's what we're doing. We're just doing it slower. Okay? So technically, I multiplied this whole thing together, this one times this one, all at the same time. But when you're multiplying bases, you add the exponents of like bases. So this x has a like base. I can't multiply it times the y to change it. Technically, this is being multiplied here because there's no symbol, but it is all multiplied. Okay? So, this is where practice is going to be helpful when you're doing this. All right, let's look at rule 2, and we'll go a little faster. This is x to the a divided by x to the b equals x to the a minus b. So when you divide bases, you subtract the exponent. Oftentimes when we're dividing, we're going to write it x to the a divided by x to the b. Okay, so if we do, again, a real example, let's have x to the fifth. All right, sorry, x to the, how about stop being annoying, divided by x to the third. That would be, if we want to expand it out like we did in this example over here, be x to the fifth divided by x to the third. Anything divided by itself is 1. So when I'm dividing here, x divided by x is 1. X divided by x is 1. X divided by x is 1. All I'm left with here is x squared. So when you're left with that, that's x squared. So 5 minus 3 is 2. So it's always the top one minus the bottom one, and the answer goes in the top. Okay? So again, 14 and the 2 here, that's just going to be dividing for this answer. They're not technically bases, they're just coefficients. So it's 14 divided by 2 is 7. And then we have x to the 6th divided by x to the 6th. Well, if you can recall, this is anything divided by itself is 1. So that's just going to be gone. It's 1. So it's 7 times 1. You can write that if you want, but I don't. And then y to the third is up on top here. So y to the third has nothing to divide. There's no y in the bottom. So that stays where it is at the same time. So you could write it like that, or 7y to the third. Okay? And then we have rule number 3. We have a power to a power, meaning we have this power here, and it's got another one with the b. Okay, when you do that, you multiply exponents. I like to remember to do this because whenever we multiply exponents, whenever we have parentheses, we think of multiplication in math, that we distribute, and that's exactly what we do. We distribute this exponent through. I'll do a regular example if you want, so let's do x to the x squared to the third power. So it'd be x, I could expand it, x squared times x squared times x squared. And again, you could expand it again and go back to this rule. So that would be x to the sixth, 246. Okay? So now, when we do an example like this, it's pretty straightforward. The only problem is that the 3 and the y don't have an exponent that we can see. So like we did back here, where we put the 1 on, you're going to want to put the 1 on both of them. So we're going to make this 3 a base also, because otherwise you can't do it. And we just take that 4 and distribute it into each piece. So it's going to be 3 to the 4th, because 4 times 1 is 4, 5 times 4 is 20, and 1 times 4 is 4. And there we go. You can figure this out. What's 3 to the 4th power? 81. And there we go. So I did some examples. These are a lot because it is review, but I'm trying to go slow also. So it's an interesting conundrum with these problems. But I did 3 rules. You have to understand the 3 basic rules. Now I'm going to do a few examples. You could always try them yourself. Follow me. See if you can do it with me. However you want to do it is completely fine. But I'm going to do them. And then you have a couple examples that you are going to submit to me that may be similar. Usually mine are a bit more complicated than what yours are going to be. So we'll see how it goes. And then if you still don't understand it, I go over it again in class the next day. And we do practice problems to even make it that much better. Okay. So it's x to the 2x plus 3, and x to the 4x minus 7. We're multiplying these two together. That's what this symbol is right here. We're multiplying. So when we multiply bases, we add the exponents. So the exponents aren't 5 and 2. They're that mess. So all you have to do is you are going to add the exponents. You don't have to do it any special way. You could just do it in your head. Or you can do it like I do and line them up so I'm combining like terms. So I added the 4 and the 2 because when you're adding, that's what you have to do. And then our final answer is x to the 6x minus 4. So when I multiplied these bases, I just simply added these 2 exponents. So you have to just figure out which rule you're doing and then do the rule. Because this is Algebra 2, we have a bit more exciting questions, okay? So when you're dividing here, when you divide, you subtract exponents. So this line right here means divide. Okay, so we know our answer is going to be x, because this is our base, to an exponent. But my exponent is subtracting this one minus this one. So remember, with subtraction, 2c plus 4, I'm going to subtract the bottom one. So the top one stays the same, the bottom one gets subtracted. So I have to change the signs of both of those. Keep change, and then add. So that's how I subtract. I change my signs and then add. If you do it a different way, totally fine. I get math. You can do what you want. So it's 2 minus 1 is 1c, and 4 plus 2 is 6. Okay, and so that's my answer. This next one combines a couple of things. Okay, so you have to just decide what you want to do first. Mathematically, it doesn't really matter which one you do first. I like to simplify. Oh, no, this is an x sorry, an x and a y. So this is different. I can't simplify this inside at all, the inside of the parentheses at all. So now that I look at it, I can't do that. So all I can do is raise this whole mess to this exponent. So this, you have to figure out what are the exponents. So 3a is an exponent, 4c is an exponent. 4 doesn't have one, so I give it 1. 3 doesn't have one, so I give it 1. And then remember, I multiply every exponent by that 2. So it's 4 squared x to the multiplying, okay, to the 6a, and 3 squared y to the 8c. That's perfectly good, but we do like to know that you know math. So 4 squared is 16, x to the 6a, and 3 squared is 9, y to the 8c. And that would be your simplified solution. Okay, so here we are. We're multiplying. See, this is what we're doing. We're multiplying bases. So when you multiply bases, you add exponents. So notice up at this one, up here, my x stayed the same. X and x are the same here. So when I multiply the bases, I'm just adding the exponents. So the final answer here is 3 to the 4 plus a. This 3 stays the same. So let me just give you an example in real math so that you don't freak out on me later. So let's do 3 squared times 3 to the third. 3 squared is 3 times 3. 3 to the third is 3 times 3 times 3. How many are there? 1, 2, 3, 4, 5. Nice. That's brilliant, Kirsten. Okay. So 3. Notice it's not 9. It's 3 to the 5th power. So just like this one, this is a isn't a number here, so I can't actually get the 5, but it's the same idea. Okay? Bases stay the same. The exponent is what's doing the multiplication. All right, so 2 more. We'll do these a little quicker. Okay, the 5 is an exponent, and it's 2x is being raised to the 5th power, so I have to put that 1 on there. So it's 2 to the 5th, x to the 5th, and then 2 to the x cubed. Okay, we can do the math here. 2 to the 5th is 32. X to the 5th, I can continue. I'm just going to do it this way. X to the 5th, x to the 3rd. So then I did that simplification. Now I have to simplify it more. When you're finished, each variable should only have one exponent. You shouldn't have like x's in 2 spots. See how x is here and x is here? That shouldn't happen. So we need to simplify it. So we have 32 divided by 2 is 16. And then this is division, so it's 5 minus 3. So we're dividing, so we subtract the exponent. 5 minus 3 is 2. So whenever I divide, whenever I subtract those exponents, the answer always goes in the top. So technically, this is the answer. We don't usually put it over 1, just because why bother? Just extra ink we're using, or penciling lead. And then here we are, the last one, 10 to the 3rd power over 10 to the a. We're dividing, so we subtract the exponents. So 3 minus a is the exponent. And remember, the base stays the same. Okay, you probably can hear my dog in the background whining. She wants me to throw a ball for her. So you have a wonderful day, and we'll see you later.